Welcome, welcome! If you're watching this video, you just need to focus entirely on simplifying radicals. So let's get started. If you look at the numbers on the list, on the very top, these are all the perfect squares. The way you build the list off without memorizing it is just by remembering the concept of it's counting numbers starting from 1 times itself. So 1 times 1 gives you 1, 2 times 2 gives you 4, 3 times 3 gives you 9, so on and so forth. The reason why we care about this is because when we split it apart non-perfect square roots, we're going to split it into one of them being the largest perfect squared and one of them being the most reducible form. So let's start with the square root of 72. 72 falls between 64 and 81. And we say, what is 72 perfectly divisible by? So we check with 64 first, from largest to lowest. Is 72 divisible by 64? You say no, because you get a decimal answer. 72 divided by 49? No, doesn't work, still a decimal. 72 divisible by 36? Works perfectly. Because if it is divisible by 36, the other factor will be 2. Then you just evaluate what the square root of 36 is, which is going to be 6, and the square root of 2 is just right there with it, and therefore this is your final answer. 6 times the square root of 2. Second example, we have a number in front of the square root of 27. Don't care about the 4 yet. We only care about the numbers in front. We only care about the radicands, the number inside first, then we care about it afterwards, the 4. So the square root of 27 will fall between 25 and 36. Is 27 divisible by 25 evenly? You say no, decimal answer. 27 divisible by 16? No. Is it divisible by 9? Yes. And if you did divide it by 9, you would have gotten 3. So that's what we split it into. Well, 9 is our largest perfect square. If we evaluate it, it's going to be now 4 times 3 times the square root of 3. And now we multiply the two outside values together. 4 times 3 gives you 12. You have the square root of 3. And therefore, this is your final answer to this problem. Square root of 53 is a special problem because if you try to divide it by the perfect squares, you're going to see something odd. First of all, you put 53 between here, and you say, is it divisible by 49 evenly? And you say, no. Decimal answer. 36, no. 25, no. No, no, no. You get all the way down to 1. Well, that's because 53 is not divisible by a perfect square, and in fact, if we go further, it's a prime number, so it can't be broken apart. Because of that situation, you cannot simplify this any further, and therefore that problem is your answer itself. As for the last example on this slide, we have a negative 49 inside the square root with the 2 in the front. If you have a negative in the front of the radicand, you just separate it immediately. So you say 2 times, and you split the square root into a negative 1 times the square root of a positive 49. So now we can focus on just evaluating what the square root of 49 is, because we already know what the square root of negative 1 is. It's going to just be I. Now here's the thing about 49. It's already on the list. So if it's already on the list, that means it's a perfect square. So the square root of 49 is just going to be 7. And again, we already established that the square root of negative 1 is just I. Multiply the two values together, the two numbers. So the final answer is 14i. Now for the last example for this video, we have the square root of negative 54. So this is now where we are going to simplify a non-perfect square with a negative radicand. First step, separate the negative 1 immediately from the value itself. So square root of negative 1 times the square root of positive 54. Now we say, all right, where does 54 fall between? It falls between 49 and 64. Which one is 54 divisible by? It's not going to be 49. It's too big. It's going to be a decimal answer. 36, no. 25, no. 16, no. 54 is divisible by 9. So therefore, this is now going to be rewritten as square root of negative 1 times the square root of 9 times the square root of 6. Evaluate everything now. Square root of negative 1 is I, square root of 9 is 3, and square root of 6 stays the same because that is not reducible. So our final answer is going to be rewritten in 2 different ways. You could rewrite it like this, 3 square root of 6 followed by the I at the end, Or you can rewrite it where I is in the middle, so you say 3i square root of 6. Both answers are the same, so just pick whichever one you're more comfortable with. So there you go. That's the review on the radicals.